Hello and welcome to another section in further mathematics. In this section, we'll be looking at a topic, binomial theorem. The binomial theorem. But before that, let us look at our previous lesson. Okay, welcome back. You know, in our previous lesson, we talked about binomial theorem. We went ahead in stating the formula for binomial theorem. I told us that when you have x plus y raised to power n, binomial used combination in explaining terminologies involved in expansion of numbers. So this becomes x raised to power n plus combination n 1 x raised to power n minus 1 y plus n combination 2, this n combination 2 x raised to power n minus 2 y square plus n combination 3 x raised to power n minus 3 y cube plus up to the point where you have y raised to power n. Now this is known as the binomial theorem. Now, with this application, we were able to do justice to some questions in our last class, and I would like us to continue with some of these questions to enable us increase our level of proficiency when it comes to using binomial theorem in solving questions. Now, I want us to solve this. Expand 2 plus 1 over 2x raised to the power of 8. Now, when we have a question like this, remember, we are so much interested in getting the x and the y value before we start solving. So one of the things we need to do now is to express this equation, which is the same thing as 2 raised to the power 8 in bracket 1 plus 1 all over 4 x raised to the power 8. So the equation becomes like this. So we are now interested in the bracket. Now when we want to deal with the bracket, we will have to apply binomial theorem in this equation. So we now have 2 raised to power 8 being the constant. Now the bracket term now becomes, remember the value of our x here, if you want to compare this equation, is 1. The value of our y is 1 over 4x, and we have our n here being 8. So let's now apply the binomial theorem in analyzing this equation. So we now have 1 plus, the next thing is n combination, and our n, remember, is 8. So we now have 8 combination 1. Then our n is, our x is 1. So 1 goes here. So we now have 1 over 4x without a power in the first one. Plus we now have 8 combination 2. Our x is still 1, so 1 raised to power anything will give you 1. While the value of our y is 1 over 4 in bracket x raised to power 2. The next one becomes 8 combination 3. Then we now have 1 over 4 x raised to the power 3. The next becomes 8 combination 4. Then 1 over 4 x raised to the power 4 plus 8 combination 5, 1 over 4x raised to the power 5 plus 8 combination 6, 1 over 4 x raised to the power 6 plus 8 combination 7, 1 over 4 raised to the power 7. And lastly, I told us that whenever you have the value of your n and your r as being equal, then you stop at that point. So the last one is 8 combination 8, 1 over 4 x raised to the power 8. So we'll be stopping here. You open the bracket. Now after expanding this, you now have a equation to be in 2 raised to the power 8 in bracket 1 plus, this becomes we now have it to be 8 bracket 1 over 4x plus 8 times 7 all over 2 factorial. Now we are converting this combination to this. So this is the second one, n combination 2, where our n is 8. So we now have 8 times 7 all over 2 factorial. Then have 1 all over 4 in bracket x raised to power 2 plus 8 times 7 times 6 over 3 factorial, where we have 1 over 4x raised to power 3. Now up to the point where we have 8 combination 8, which is 1. That is, our y value becomes 1 over 4x raised to the power 8. Now we continue by writing 2 raised to power 8 in brackets 1 plus 2x plus 7 all over 4 x squared plus 7 over 8 s cubed. Now plus to the point where you get 1 over 4x raised to power 8. That's for the bracket. Now remember that we are given a question that says 2.005 raised to power 8 as this. So now we now put it into the equation. We have it as, we put 1 over 2x, 2 plus 1 over 2x to be equal to 2 plus 0.005. Now one of the things I want us to understand at this point is, remember we have 2 at this point, we have 2 at this point. Now we want to compare the two equations. You see that 1 over 2x is now equal to 0.005. Now I would like us to do a normal cross multiplication. If you cross multiply, you have 2 times this. Cross multiplication, you have 2 times 0.005 to be equal to 1. So when you now do 2.005 equal to 1, then you now have it to be equal. So the value of your x will now be, okay, this is 2x equal to 1x. So x will now be equal to 0.01. So the value of our x is equal to 0.01. We'll now add it into the equation to solve for our final value. So substituting it now, we now have 2.005 raised to power 8 is now equal to, let's go back to our original equation, 2 over 8 in bracket 1 plus 2, 0.01. This is 0.01 plus 7 over 4. Remember, we are substituting the value of x now in our original equation, 1 all square plus 7 over 4, 0.01 all cube, to a point where you have 0.0001 squared. So our value is now 256 plus 5.12 plus 0.0448 plus 0.000224, which is equal to 261.17. That is 5 significant figure. So the value of our equation 2.005 raised to power 8 is equal to 261.17 into 5 significant figure. You can do a check of this using your calculator. Now I would like us to go into solving one more question before we can call it a wrap to this topic. Now what I want us to do is, okay, let's call this example 2. Now on this, let's expand 1 plus 2x raised to the power 5. And remember, whatever result we are having here, we use it in solving the value of 1.02. We'll be getting the value of 1.02 raised to power 5. Now this equation we'll use it to analyze. Now let's state it clearly. This is equivalent to, remember our formula, binomial theorem. 1 plus is 5 combination 1 we now state okay, this is 1. You have your 2x, which is 1. Then you now do the next one, plus 5 combination 2, 2x raised to the power 2, plus 5 combination 3, 2x raised to the power 3, plus 5 combination 4, 2x raised to the power 4, and lastly plus 5 combination 5, 2x raised to the power 5. Remember what I told you? I said when you get a situation whereby the value of your n and r is equal, that's we have 5, 5, then this should be the end point of your combination. So let's move further in expanding the bracket. So this is 1 plus 5 combination 1 is 5. We did it using combination. I told you that we have 5 combination 1. This should be rough 5 combination. Now 5 factorial over 1 factorial. 1 factorial times 5 minus 4 factorial. So this is the same thing as 5 over 4 factorial, which is equal to 5. So we are applying this here, which is 5. Then we bring down the value of our 2x at this point, plus 5 times 4 over 2 factorial. Then we now have 4x squared here, plus 5 times 4 times 3 over 3 factorial. We now have our 8x cubed. Now with this, since we've gotten up to this point, then we now have plus 5 times 4 times 3 times 2 over 4 factorial. We have 16x raised to the power 4, then plus 32 raised to the power 5. So our equation becomes 1 plus 10x plus 40x squared plus 80x cubed plus 80x raised to the power 4 plus 32x raised to the power 5. Now this is the equation, but remember we want to solve the value of 1.02 raised to the power 5. Now let's apply our master equation into it. So we now have it that 1.02 is equal to 1 plus 0.02. Then we make it this way, raised to the power 5. This becomes our x value, y this becomes our y value. So we now use the binomial theorem. But remember, putting 1 plus 0.02 to being equals to 1 plus 2x. 1 goes with 1. We now have 2x to be equal 0.02. So with this, x is equal 0.02 divided by 2. That makes our value, 2 here is 1, so the value is 0.01. So the value of x is 0.01. Now let's go back to our equation. We have 1.02 raised to the power 5, which is equivalent to 1 plus, now we are substituting the value of x as 0.01 plus 40 0.01 squared. The next will be plus 80 0.01 raised to the power 3 plus another 80. Remember our original equation. This is the equation we are using in substituting the value of x. So plus 80 have 0.01 raised to the power 4, then plus 32 raised to the power 0.01 raised to the power 5. So the value becomes 1.10408. If you do the punch in your calculator, you discover that the value of this is equals 1.10408. I would like to say a very big thank you for being part of today's lesson. I think we've just done justice to the binomial theorem, using it in solving for different values and expanding our variables. So, but I want you to do something now. Just get ready to take the test that will be coming up shortly in front of your screen. Also do well to always use this lesson note on the platform for better information on the topic we've just discussed. So thank you and see you in our next lesson.